A very warm good evening to one and all. We are Alexa Developers SRM, officially affiliated with Amazon Alexa. Alexa Developers SRM pursues to be a team which strives to impart knowledge and build a community of voice developers. Leveraging the enormous talent of our passionate and determined young individuals, students can compete with people of same interests in the tech world. And we also conduct informative workshops, webinars, and hackathons. I am Aditi Goyal, a business associate at Alexa Developers SRM, and I take great pleasure in welcoming you all to the day 3 of the Sensei training session, where we are going to dive deeper into the world of Node.js. Sensei is our flagship training cum mentorship program. The first of its kind among all campus clubs, Sensei aims to help learners start their way with Alexa skills, AWS services, web development, and other related technologies. I would also like to take this opportunity to extend my deepest appreciation to our benevolent sponsors, without whom this event would not have been possible. It is our great honor to have Seaport AI as our title sponsor, GrabOn as our official savings partner, Sashido as our ideation partner, TechCrawler as our publicity partner, and Rebel.it as our technical sponsor for the event. We are eternally grateful for all their support. Now, before I invite my colleague Vashisht to take over the session, participants, please note, during the session, if you have any doubts, please feel free to drop it in the chat box or ping us in our Discord server, the link to which will be available in the chat box. Our team officials would love to help you out. Let's begin with the learning, shall we? The floor is all yours, Vashisht.
Thank you, Aditi. Hello, everyone. This is Vashish, and today I'll be taking you through Node.js. So we have 3 agendas for the day. The first one is going through HTTP requests. At the second, we'll be creating a RESTful API, and lastly, we'll be getting to know a service called MongoDB. So let's start with the first agenda, which is HTTP requests. So what are HTTP requests? HTTP defines a set of request methods indicate the desired action to be performed for a given resource. Let me give you a few examples of HTTP requests. They are get, post, put, patch, delete, copy, and so on. Today we'll be emphasizing on 4 types of requests, which are get, post, put, and delete. So let's start with get. The get method represents a representation of specified resource. Request using get should only retrieve data. So whenever you are browsing using any web browser, you only send get request and you will be getting data. Next comes the post request. So the post method is used to submit an entity to the specified resource, often causing a change in the state of server. For example, you are filling a form. You are entering all the data and clicking the submit button. As soon as you click on the submit button, at the backend in the database, a new object will be created with your name. Next is the put request. So the put method replaces all your current representation of the target resource with the request payload. For example, you're filling up a Google Forms. At the end, you have got an edit forms option. You are clicking on edit options and you are changing few of your data. So what Google will do is that it will first identify your particular object, and then it will completely replace that object with a new one which you have created. Lastly, we have the delete request. So as the name suggests, delete request is used to delete any specific resource from a database. So now as we are done with the theory part, we'll go on to our second agenda, which is creating a RESTful API. For this, we'll be needing 2 services, 2 software named VS Code and Postman. And through this, we'll be covering all 4 HTTP requests which we have learned just now, which is get, post, put, and delete. So let's move on. So first, I'll request all of you to download the Postman, postman.com/downloads. You can download the app here. Let me open it. So when you will open Postman, you will be getting a similar kind of interface. So what exactly does Postman does? So if we'll go to a browser and we'll send any HTTP request, we'll be getting the formatted HTTP request. But here we'll be getting in the code. Let me show you an example. Let me go to Google. I'm sending a GET request here. Now here I'm getting the raw code of Google. So we'll be using this today. Now let's head over to our VS Code. So I have created a file. I'll be opening the terminal. Here, first we have to initialize npm. So just type npm init. You can just hit on enter. Okay, yes, again enter. So here we are done. In the previous session, we had learned how to install Express. So can any of you try to tell how an Express server is installed using npm? I'll wait for 2 minutes. Correct. It's npm install Express. Instead of install, you can just type I. So here our npm is getting installed. I'll create a new file named RESTful .js. Here first I'll open Express. Show our database. To show our data, we'll be using the fs module. But remember, in the last session, we had used a normal text file. But in this session, we'll be using a separate type of file, which is called as JSON. So the full form of JSON is JavaScript Object Notation. Equal to file. Does anyone remember how to declare a port? I'll be waiting for your reply. I want you to answer how will you initialize a port? I'm giving you a hint. Use app.listen. Okay, no problem. I'll tell. It's app.listen. followed by we have to pass in a code. So I am passing code 3030 and in an arrow function, we just type console.log you are at code 3030. Let's try to run this. So for that, perfect. We are at code 3030. So first we will be declaring a simple get request. So for that, we have to use app.get. By this, we'll be going to the home route. And we have to pass in the parameter request and response. And just for a try, we'll do as let's.send. So let me run my server again. Now let's go on to Postman. Here I'll be running the local host 3030. We are getting high. So now let's once concentrate talk about the JSON file. For that, it's a simple extension. I'll name a file called data as a JSON file. We are going to so in this particular file, all our data will be stored for the RESTful API. So this will be acting as an array. So we'll just declare the square. We'll add the square brackets here. And in our main JavaScript file, we'll be assigning app.use express.json. So now we have to read our JSON file and display it when the GET request is called. So first we'll be storing the data of our JSON file into a file buffer. So let me declare let file buffer is equal to fs dot read file sync data JSON. And we have to mention about the encoding. It is UTF-8. Now we will be displaying all the data. For that, we have to do this. JSON bracket catch on JSON dot parse file buffer. Save it. Looks like I didn't save this. Now let's restart the server. By starting, let me send a GET request here. Look carefully at the body. So here we are getting the square bracket, and if we go on to header, it will identify as a content type to application/JSON. So right now we are successfully able to read the content inside the file. Now our second goal is to enter data inside that file. For that, we'll be using the post method. For that, it will be app.post. Again to the home route. Then request response. So here, first we'll be reading all the data which is there inside our file. So file buffer is ready. Now we'll be creating an object, a temporary object. So let us name it file object. And in that file object, we'll be sending all the data whichever is there in our file buffer. For that, we have to go on JSON dot parse file buffer dot to. A few of you might be wondering, why are we using toString here, whereas not in the first GET request? So we are using toString so that it will be easier for our compiler to read the data and go on. Now I'll be declaring one thing, which is incoming data, which will be having the body, which will be typed, request.body. Now we have to push the data into the file object. For that, it will be file object dot push normal bracket, curly bracket. Inside that, you have to type name colon incoming data dot name, the comma, and we'll be also accepting the age. So you have to do age colon incoming data dot age. Now it's time to write our data. For that, we'll be using fs dot write file sync. We'll be finding a file which is data.json, and we'll be sending our file object. For that, we have to do JSON dot stringify data, stringify file object. And just to confirm, we'll be sending send data sent. Save it and restart our server again. Okay. Currently, our file is empty. So now we have to enter the body. For that, we have to go to body, raw, and through the side drop-down menu, you have to select JSON. Over here, you have to type open the curly braces. Inside semicolon, type name, colon. I'll type my name here, comma, age as 18. Here we'll be sending a push request, so push, send. Your data is sent. Now let's go and get a GET request. Perfect. Now all our data is coming to our JSON file. Let's do one more push request. This time let's name it as try, and we'll keep the age at 49. Data sent. GET request. Perfect. This is working. You can head back to your VS Code and check your file here that your data is. Now, here I want to change the age of try from, let's say, 49 to 90. So for that, we'll be using the HTTP request put. So to start, we'll be using app.put as a home route. Request and response arrow function. Similarly, as you do, first we will accept the thing. We will read the file, create a file object, and we will get the incoming data. From here, now we have to particularly match which name is it, for which particular name do we want to change the age. So for that, we'll be using a for loop for let I is equal to 0, I less than file object dot length I plus plus. For the cases, here we'll be using a statement if incoming data dot name is equal to file object at ith position dot name. We'll be replacing the age to file object ith dot age is equal to incoming data dot age. Let's write it. We are going to write in the same way as we have done in the post request. Instead of data send, we'll be like write data updated save it. Again, restart your server. That to 3030. Now over here, let's try the age to be at 90. We'll go to the put, we'll send it. Okay. The data is updated and sent. Let's get our get request. Perfect. It's working. Let's try once again. Let's create a new object named free age as 2. Send it. Get a get request. 3 is coming here. We go to a post request and change the age as 100. Perfect. It's working. Now I want to delete 3. So for deleting, we'll be using the delete HTTP request. So for that, it will be again app dot delete. Again, closing the request response arrow function. The same thing which we had done for post and put. We're going to copy that. Keep it here. So our file buffer, file object, and incoming data are initialized. You have to search for the particular object from the array. So for that, we can use an array function. So that we create a new object. So let new file object is equal to file object dot filter. And inside here, we'll be adding a variable single object. And here we'll return all the data which does not matches the name. So it will be return single object dot name and not equal to incoming data dot name. So we write a file fs dot write file sync to data dot json. This is a JSON object to JSON dot stringify new file object. Therefore, our reference to res.send deleted. Again, let's restart our server. Restart it. We'll send a delete request and we'll delete 3. So just passing the main variable is enough. Delete. We'll go on get a request. Perfect. It's delete. Let's try again with try. Try. Delete. Delete. Let's get a get request. Perfect. So right now only one object is there as expected. So here we have successfully created a RESTful API. Note, there are many more types of APIs available for doing the same job, but we are following here the RESTful API. Now let's go into our theory part. Now let's go into the MongoDB. So MongoDB is basically a database provider. So now you must be wondering, what is a database? A database is an organized collection of data generally stored and accessed in electronic form from a computer. So there are mainly two types of database, SQL and NoSQL. SQL stands for Structured Query Language and NoSQL stands for No Structured Query Language. So in structured query language is a relational database management system with a predefined schema. Whereas for NoSQL, it will be a non-relational relational database management with a dynamic schema. Here are a few of the provider, the very famous Oracle for SQL, and we are going to be using MongoDB, which is a NoSQL. Right now, we'll be using the service called MongoDB Atlas, which is a cloud-based data management system provided by MongoDB. So now can you all tell me, why do we have to use a cloud-based data management system instead of a local database management system? I'll give you 2 minutes. Let me wait for the reply. Anyone? Just give it a try, no problem. Okay, looks like some. The main advantage of cloud-based data management system are it reduces cost, it's flexible, it's really easy to scale, and can be accessed from anywhere. So now let's go in for a hands-on session with MongoDB. Here you'll be requiring MongoDB Compass and a MongoDB account. So let's head over to our browser. Let's go to the web page, mongodb.com. Here you can go on to Cloud and Atlas. You can create a absolutely free account by signing in just with your Google account or sign in. I already have an account, so I'll head on to sign in. So as soon as your account is created, you will be landing on this clusters page. So let's build a cluster first. Click on build cluster. You use a shared cluster, which is absolutely free of cost. I'll be using AWS server, and the nearest server to me is Mumbai AP South 1. So I'll go on that. Make sure in the cluster tier, we have selected M0 sandbox. I'll leave the rest as default and even the cluster name as cluster 0. Let's click on create cluster. Now this might take some time, around 5 minutes. So till that time, we can do a few of our other settings. Go on database access. Here you have to assign a user. So click on add new user. I'll give it as Sensei. And in the database user privileges, click on Atlas admin, add user. Our user is successfully created. Now we have to give an IP access. So we are going to give a global access. For that, you have to type 0.0.0.0.0. Confirm. So through this, your cluster can be accessed anywhere from the globe. This process will take around 2 minutes. You have to wait for that. Until then, we'll just create a new file. We'll name it as mongo.js. So here we'll be using again an Express app. So we'll be doing launch express is equal to require express launch dot app. Launch app is equal to express. And I'll initialize the code as app dot listen 3030 arrow function console.log you are at code 3030. Let us save it. And let's check whether our cluster is ready. So as you can see here, our cluster is ready and our network access is also active. So head on to cluster, click on connect, click on connect using MongoDB Compass. If you have not installed MongoDB Compass yet, you can install it from, I don't have MongoDB Compass, but I have it. So I'll head on to copy this link and I'll open MongoDB Compass. Generally, it takes about a minute to open this app. Okay. So this is its basic user interface. Here you have to paste that link and type your password. No, never share your password with anyone, or else they can easily access your data. Let's click on Connect. By default, 3 databases will be made for you, which is the admin, config, and the local. We'll create a new database, and let's name it as Alexa. And we'll create a cluster inside that, which is Sensei. So we have created the database and a collection here. Let's open that. Now let's import some data. For that, we will add insert document. We still have one object left in our JSON file. We'll open our JSON file. We'll copy the same. Let's copy and paste it over here. Insert. So our name and age has been come here, but here a new entity is also there, which is called the ID. It is automatically generated by MongoDB. So you need not worry that why is it here. So now let's head over to our VS Code to try out the application. Before starting, you have to install the npm. We have to install MongoDB using npm. So for that, you have to write npm I as in install MongoDB. You have successfully installed it. Now, so as we have started the Express, we will similarly declare it as const MongoDB is equal to require MongoDB. Now here we need here we have to declare a few more things before directly accessing our database. For that, we declare a client first. Const client equal to MongoDB dot Mongo client. Here we'll in the practice we'll pass process env dot Mongo in tabs. Open databases. And inside this you have to type use unified topology and assign is add true. So we'll declare a variable called collection outside. So let collection. Now we have to connect with a MongoDB client. So for that we will be declaring a function named test function. It's going to be an async function. We had learned about async function in the day one of Sensei. You can go through that video if you have forgotten about it. Arrow try function. Inside this, we are going to do a try and catch method. So if by chance we are not able to connect to our Mongo server, then it will show an error. So for that, we will try, open curly braces, type await is client.connect. And it's, when this process is completed, that time you can consider log Mongo connected. And make sure to be in double quotes. You have to assign a collection. For that, it will be collection is equal to client dot db collection. And here I want to store it to the Sensei collection, which we have just created. For that, Sensei. So if now we have an error, we will go on to catch the error. Here, let's type error. We console error. So for that, console.error in brackets we pass in the error, and we will stop our process with process.exit -1. Now, before starting a server, we want to check if our Mongo client is connected. So for that, we just type test function dot n. So this whole app.listen will go inside this function. Okay. Now let me indent this properly. Okay, I get that. I'll try this part again. Yes. About 10. An arrow function. Inside this arrow function, we'll be starting our server for that app.listen. 3030. And again, inside an arrow function, console.log. You are at port 3030. Is that answer? Give me a second. Yeah, I forgot to mark the arrow. Right now, we have to connect our server, which we have to our database here. So we'll be copying again the same link. Let me paste it here. I'll change the password to Sensei. Here you can see the slash test. By default, we'll send this link. Then it will be creating a new database as we don't have a test database here, and it will go there. But I want to add everything to our Alexa database. So for that, we'll just change it at Alexa. We'll copy this link, and then here you have, in the terminal, have to type Mongo is equal to then the link followed by node mongo.js. Enter. We have successfully connected to Mongo and we are now at port 3030. Let me just stop the server. Let me just edit this set of code which we have used as you're going to use the same function, same format. Before going through this, you have to again initialize app.use express.json. And for Express to work seamlessly with Mongo, we will be using app.use express.url encoder. Here in brackets, we will be typing as extension as true. Now we are ready to go with our code. We'll first go with our get. So first, let me delete this. We'll be sending all of the data is equal to await is collection dot time open on regular brackets and inside that the curly brackets and dot to array close bracket here we will be sending s dot json bracket the data. As we have used await here, we have to make this function as async. So we have to type as async, save it here. Let me start the server. I'll be using the same here. But before that, let me clear my terminal. Run the command, and you have on the screen. So let's go to our Postman. Here, and the same thing should come here as we had passed in the same data, name as Ashish and age as 18. So let's send it. Perfect. Now name as Ashish and age as 18, and with that unique ID, we are able to see all the three. So now let's go on for the post function. So for post, we will just do initially an incoming data. Data is equal to request.body. The next line will be let data is equal to await. Sorry, you don't have to declare put it in data. You can straight away put it in your collection by await is collection dot insert one, and in that you can pass in the incoming data. For reference, we just do rs dot in data. Save this file. Restart the server again. Okay. That's an error highlighting await because we have not made it as an async function. So it as an async function. Save it. Here it comes to run it again. They are connected to Mongo. Fantastic. Now let's go to our server. Here with the same, we have to go to body JSON. Here let me pass as the name. Let's keep the name as Chennai and age as 2000 and the same number. Let's go to push, send. Okay, data is sent. That is going to get. You're able to see. You can cross-check it in your MongoDB Compass app. You can just set the refresh icon. Here you can see Chennai with the age of 200. Then let's head over to put request. For put request, again you need the incoming data. So I have here, I'll delete everything. And let me delete everything else. Let incoming data is equal to request dot body. Now here we will be our existing data for that. Let data equal to await collection. Here we will directly find, and we have to find one particular record. So for that, collection dot find one normal bracket, and inside curly braces you have to type name colon space incoming data dot name. So here, so we'll change. Now we can change the age. So as data dot age is equal to incoming data dot age. Now we have to replace one particular record. So for that again, await collection dot replace one bracket. Let's mark it as name colon data dot name, and here we will be sending the data which we have edited. So comma data. Save it. So this over. Before that, again we have to make it as async. So async. Save. Restart our server. This is working. So let's change the age from 300, sorry, from 2000 to 2500. Select the request. Data updated and send. Let's get the get request. Perfect. It's edited here. If you want to cross verify, you can always do it in your MongoDB Compass. Here you can see 2500. Now let's go to the last step, which is the delete. For that, again, we need the incoming data. Which record is there? I'll delete all the rest of the files. After this, I'll just directly do await space collection of one open brackets, open curly brackets. Inside that, pass on the name colon space incoming data dot name. So here you'll be first finding the object with name as incoming name provided that before, and that particular record will be deleted from the database. So that's it. So we have to make it again async. Save it. Restart your server. For closing your server, it's Control C. And I'll just copy it. Run it. Perfect. Now, in a Postman, delete all the things. I will delete Chennai, delete send, delete. Let's check, cross check it with the get request. Deleted. I will delete the refresh. deleted, you get a get request, empty. Again, cross-check it with your MongoDB Compass, hit refresh, and you can see all the data has been deleted. So with this, today we have learned how to create a RESTful API first with a normal FS module using a JSON file separately. And next, we have made the same application using the MongoDB Atlas service. So here we come at the end of our session. You can connect with me at LinkedIn and GitHub. If you have any questions, you can always ask us in our community at community.alexa.srm. And your feedback is really valuable for us. You can give your feedback at feedback.alexa.srm.com. Thank you.
Thank you for the amazing session, Vashisht. It was truly enriching. Before you leave, please take a minute to fill the feedback form. Your insights are truly helpful to us in shaping our future events. We hope all of you had an amazing time with us. We can't thank you enough for joining in. You've been a lovely audience. The recording of the session will be provided tomorrow, and we hope to see you again for our fourth session on the 7th of February.